So first of all, I just want to say a big thank you to all of you for joining. I'm just feeling really happy to be here, but I'm definitely more happy that you are here, so thanks so much for coming. My name is Ingo Philipp. I'm on the product management team at Tricentis. Tricentis is a software company located in Vienna, the beautiful capital of Austria. And maybe you know already our flagship product, the Tosca Test Suite. But don't panic, today I won't talk anything about our product. I want to exclusively focus on the future of testing. Now then, in order to safely dive into that topic, I first would like to make sure that we all speak the same language, that we all have a shared understanding about my interpretation of the future of testing. And I want to start with this. Your future depends on what you do in your present. And this just means your future is not my future is not your future. Future in general is a highly subjective term. It's by no means objective. It depends on your perspective. It depends on your current situation. And so your testing future depends on how you are testing today. And so your testing future is derived from your testing present. Now, what's the testing present I'm going to talk about? Well, when we talk to our customers, when we talk to our partners or to analysts, we constantly see that picture on an average software development project. We see that most of the testing effort still goes into manual testing, about 80% or so. Right? This includes manual test case creation, the execution, the maintenance, but this also includes manual test data, localization and preparation during the execution. And just a small fraction goes into automated testing, between 15 and 25% or so, where most of the test automation itself is carried out on the level of UIs, the user interfaces. Now here already we see two major issues. The first one, the obvious, right? It's manual testing. It's just the top technical challenge in any sort of app development, period. The next one is test automation itself. It's still regarded as a developer's discipline. And now from this, it becomes perfectly obvious that when you as a manual tester so heavily rely on manual testing, and when you as a plain manual tester aren't really able to create and to maintain a test automation solution, you won't be able to survive and so to succeed in any fast-paced development environment. And so we say that the future of testing for those guys out there in that situation needs to look like that. Number one, we need to achieve automation rates far beyond 85, 90%, or even higher. Number two, we need to have a key enabler at place for those high automation rates, which we call orchestrated service virtualization. Number three, future test automation must focus on API testing. That means automation driven by the usage of application programming interfaces, such as web service, for example. And number four, due to the dramatic increase of test automation, also the effort in manual testing needs to decrease dramatically. And in doing so, we say it also needs to transform into exploratory testing. Now that's the future of testing in a nutshell. And I want to guide you through all of those points in order to also tell you why. Now let's first go to API testing. Why the heck should we even think about it? Well, let's have a look at on how the degree of completion of UIs and APIs usually evolve over a certain period of time. Let's say from the beginning of a certain iteration to its bloody ending, okay? Now, when it comes to the user interfaces, we'll get a picture like this. So you will start with an initial idea on how your user interface should look like. That's maybe based on a mock-up. And then you start your UI implementation. But after the first feedback gets into the game, you most probably will rethink your UI proposal. And you most probably will redo your UI implementation. And this usually happens over and over and over again in the course of a certain cycle. And so you must be really lucky, really lucky to complete your user interface just at the end of a certain iteration of a sprint, for example. And here the question is, can you keep the pace with any agile development when you just have a single-minded focus on UI test automation? No, you simply can't do that. Now, in contrast to user interfaces, the APIs usually evolve like that. They are much earlier available in the development phase. And so you can start testing early by using those APIs. You shift your test automation to the left. And the nice side effects, API test automation, in contrast to UI test automation, is much easier to create. It's much easier to maintain. Why? Because the APIs are way more stable than the UIs, and they are just damn fast in execution. And API testing then lays the basis for what we call orchestrated service virtualization. Now, what's that thing about? Well, when we initially arrive at our customers, we usually see system landscapes that look like this. They look like disease gene networks, I would say. A huge network of interrelated and interconnected internal as well as external systems and system components, right? I mean, it depends on the zooming level. But where are you? You are right here, right in the middle of that network, right? And you need to take care about your system or your system component. But in doing so, you also need to communicate without interruptions with all your surrounding system and system components. And you also need to wrestle yourself through all of those components when it comes to enterprise end-to-end testing. But what happens in reality? In reality, most of those systems are either broken, they're under maintenance, they're under development, they're simply not accessible. And then you just say, welcome to the tester's hell, right? You can't repeat your test execution without interruption. And so you need to have the ability to virtualize. That means to simulate the communication between your real system and your surrounding systems. And we also generalize that idea in our testing projects. We also simulate the behavior and the communication of the entire systems. That means we simulate the communication between all simulated system and system components. And a nice side effect you get out of this is that you will identify a lot of critical defects, or more critical defects, at least one step earlier in your development phase. Why? Because you're simply able to investigate the entire system from any integration perspective much earlier. Now, with that, I just want to say that API testing and orchestrated service virtualization, these are the two fundamental pillars in a nutshell of our test automation strategy. And they don't just make testing easy, they make testing even possible in a world where automation is the dictate of today. But now the big question is that already the end of the story? Is automation the sole answer to all of our problems? Let's see. Let's see what happens when we move through the delivery pipeline. Here, depicted by the rectangle here. So when we do so, when we move through the delivery pipeline, we usually encounter a lot of those problems. And we need to resolve those problems. So what are these problems? Well, we have already talked about a few of them. The reliance on manual testing, the reliance on UI automation, the problem with the system's availability, and so on and so forth. But there are also other types of issues out there. For example, the high redundancy level you usually have in your test case portfolio. It's about the poor risk coverage you achieve when you execute a certain set of test cases, or the effort you spend on manual test data creation, and so on and so forth. And now the big question is, what happens to all of those problems when we take the delivery cycle, delivery pipeline, and just compress it? Because that is what actually happens, right? The delivery cycle time is an ever-decreasing quantity. Now, a naive perspective would now just be to say, well, all of those problems just move closer to each other, right? We just have less time to solve them. But what actually happens is something like this. All of those problems mutually reinforce each other. What it means is that if you can't solve one problem, you won't be able to solve another problem. So the devil is here surely in the combination. An example, if you can't get rid of your high redundancy level in your test case portfolio, you will spend a huge amount of effort in automatic test cases that do not create any added value. And that's, by the way, the biggest strength of DevOps. It doesn't solve any problems for us, it really exposes those problems for us. Now, with all that, I just wanted to say that it's not just about speed. It's really about speed at quality. It's not just about doing the things right, it's about doing the right things right at the same time. Or it's about testing harder in terms of automation, it's about testing smarter. Now, what are those smart things? Well, let me start with an observation. The observation of how the number of test cases usually grow over time. Usually, you will get a picture like this. So in some sprints, you will add more test cases. In some sprints, you will add less test cases, and so on and so forth. The number of test cases will just grow. But no matter how fast or how slow the number of test cases will grow, at some point in time, and that is what I can guarantee to you, is you will hit a limit. Let's call it a critical limit. And that critical limit just tells you that you do not have the time, the resources, and the budget to execute and to maintain all of your test cases at some point in time. And then you need to make a decision. You need to make the decision, which test cases do I need to execute first in order to remove as much as possible risk out of my system, early as possible. Or to be more radical, you can also ask yourself, which test cases do I need to even keep alive in order to keep the pace with my agile development? And without a risk-based approach at place, you can't make the decision. You simply can't make it. Why? Because a risk-based approach allows you to categorize your test case portfolios into a high, medium, and low-risk area. For example, to carry out light testing in low-risk areas and thorough testing in high-risk areas, right? And you can do already a lot with a little. That means to achieve maximum risk coverage just with a small number of those test cases. Now, that's the first perspective, our value-driven approach. The second one is test case design. Why the heck do we need that? Well, we need to avoid the fact that the number of test cases grows exponentially fast over time, right? And we need to have the right test cases at place. And that is what we usually achieve in our projects by a structured, methodical approach to test case definition, which we call test case design. Now, let's now sum that whole thing up and let's see what all those approaches can do for us. Now assume the whole white space you see right now represents your system under test. It represents the whole functional and non-functional spectrum of your system. And as we all know, there are a lot of risks in our system, right? And I'm generally talking about risks. I'm talking about anything that prevents the user to achieve his or her goals. Now, a risk can come in different flavors, right? It can be a functional issue, a performance issue, a reliability issue, a scalability issue, security issue, safety issues. These are all objective measures. But next to these objective measures, there are also subjective measures. For example, the usability, the understandability, the accessibility, or even the convenience of usage of your system under test. And now the question is, what can specification-based, manual and automated testing can do for us in a quite a radical picture? Well, by specification-based testing, you will be able to cover the most important risk, I would say. But you definitely won't be able to cover all of them. Why? As mentioned, you live in a constrained environment, right? And the only decision you have to make is how much risk left over are you willing to accept when it comes to the release of a software. Why? Because we aren't able to test everything as exhaustively as possible. We simply don't have the resources for that. And next to that, specification-based testing, as already highlighted, is mainly about monitoring known risks, where exploratory testing is about analyzing potential risks. That's the main purpose of exploratory testing. So, and it's not about the one or the other, it's about both, right? Exploratory testing is a necessity, it's a necessary add-on for test automation, my point of view. So the core benefits of exploratory testing is that you really increase your testing cross-section. Why? Because you really actively attack those potential risks. How do you do that? Well, you allow your testers to go beyond the obvious. You give your testers the freedom to create new testing ideas whenever they are required. And so you really diversify your testing. And this not only makes testing intellectually rich, it makes it more fun and it makes it more productive at the end of the day. And then, again, a nice side effect out of this is it enriches your test case design. It enriches your already existing test case portfolio. It fills gaps, right? And it's the best method, at least from my perspective, which can be naive, it's the best method for fast error detection, to provide fast but also a valuable feedback to your business and to your development. And now I would like to show you what happens when all those I've shown you I want to now show you what happens when all those principles come together at the specific customer project we've carried out the last year in the banking sector. It was about securities trading. Well, the initial condition, all of testing was in manual testing. There were 11 manual testers around. Those 11 manual testers were responsible to execute and to maintain around 5,000 test cases. They managed to execute that set of test cases in about 10 weeks. And they had no idea about their risk coverage, okay? And I'll tell you what our project charter was, and I'm not joking. They said, there's a better way to do it, find it. We want to go agile. We want to be able to create a potentially shippable product within a single week. And we accepted the challenge, of course. So what we did first is we captured, structured, and prioritized all those requirements that are part of the game. And then we mapped all of those 5,000 test cases onto that risk-weighted requirement structure. Then we made the coverage visible. It turned out to be 40%. Well, it's not so bad, because those guys really created those test cases and designed those test cases in an intuitive fashion, I would say. They didn't have really a structured and methodical approach to testing at place. And then we went on to test case design. So in doing so, we addressed the most important parts of the requirements of the whole application. So we achieved the coverage of about 90%, and in doing so, we also reduced the number of test cases by a factor of 4 to about 1,200. Why? Because in doing test case design, we also have analyzed those existing test cases. And we have identified a redundancy level, I mean, it is incredible, about 75%. By this, the execution time went down to 5 weeks. Okay, that's not so bad. Then, after that, we have applied a synthetic test data approach. And this allowed us to reduce the execution time down again to 2.5 weeks. And this tells us that those guys have spent more than 50% of their time in just finding the right test data for the test cases. I mean, that's incredible, right? And then we went to automation. We applied our model-based test automation approach. We reached an automation rate about 90%. 2/3 of it was fully based on APIs. And by this, the execution time went down to 48 hours on a single machine. And then basically our job was done. What we then did, we parallelized also test execution. That means we distributed all of those test cases over 6 virtual and physical machines in the test labs to drill down the execution time to 8 hours. But a good part of it was we have also extracted a smoke test portfolio. So we searched for the most important 7% of the test cases, covering more than 50% of the entire business risk, and we were able to execute that in about half an hour, in 30 minutes. And we've embedded that smoke test portfolio into development. And that smoke test portfolio was executed at each individual check-in of a developer. I mean, it's crazy, right? From 10 weeks now down to 8 hours full regression, and to 30 minutes or so for smoke testing. But the best part out of it is that we reduced the critical defects in production, measured over a complete year, by more than 70%. And this was mainly attributed to exploratory testing and to test case design. And all this took us 3 months with 2 manual testers. And by this, I just want to say it's really not a big deal. So I just want to say, please start remodeling also your traditional approaches for great agility. Why? Because the future starts today, not tomorrow. Thank you so much for listening. So any questions? Yeah.
Thank you for brilliant talk. And we get what is our future of our testing, because you show our current position. Mm-hmm. But as far as your current position is different, what is your future of your testing?
So it really depends. I mean, do you mean our internal testing in our company? That is what you mean? That is what you see, that that's my future?
If we already done all these optimizations, mm-hmm. and now we start think from good position, mm-hmm. what the next steps?
Okay, yeah. So I always have those 4 pillars in my mind. It's first of all classical testing. That's the situation, I've shown it before, so that's the initial condition. The second one is agile testing. Here it's most about efficient testing, right? More about test automation, I would say, and orchestrated service virtualization, API tests and stuff like this, right? A smooth tool integration, for example. The next step, I would say, is continuous testing, okay? Where efficiency and effectiveness really come together, and very embed testing smoothly into the whole delivery pipeline, from the planning component over to the coding, implementation component, testing, and also operations. So to embed yourself seamlessly into the DevOps pipeline. So that is our challenge as of today, to be honest. And when you want to step further, it's what I call AI-based testing, right? When we then talk about concepts such as the Internet of Things and the age of robotics and all these nice concepts which are out there, yeah, so that is as far as I can see, right? So our future is really continuous testing, to do testing in an uninterrupted fashion. Any other questions?
Just about the number of manual testers at the end. You started with 11. How many were left at the end? So how was the saving?
That's a good question. Thank you so much. I just had to speed up because my time was already over. No. It was not the goal to reduce the headcount. It was not the goal to reduce the headcount. The nice thing about it is, I'm not allowed to move away. Those 8 hours of regression, right? Were required for all of those automated test cases here. But we achieved an automation rate of 90%, which is about 1,000 test cases automated, right? So about 200 manual test cases remained. So now, those 11 testers, it took those 11 testers to execute those 200 manual testers about 8 hours. So what it means is that automation, the test automation and manual testing was fully aligned. We didn't want to replace those manual testers. That's okay? Did it answer your question? Yeah. Okay.
They were trying to find out what was the save overall, return on investment.
Say it again, please.
I think she was trying to find out what was the return on investment overall. What did you save cost-wise? Or did you just save on the execution like cycle because you reduced the execution?
You want to have the exact cost. I'm not able to give you that. Yeah. We'll do that later on. Yeah. But as I've said, so it took two persons for about 3 months. Okay? 2 persons, 3 months to do that. With Tosco, of course. Now I have to bring in our product. Oh, what a shame. Yeah. Any other questions? Yeah.
Could you just tell us how scalable this is? That's 11 testers. What if you have 1 tester? Would this process still be viable with 1 tester?
Yeah, I simply don't see any scalability issues, to be honest. So we've applied it for small groups, for single Scrum teams already. So those Scrum teams are usually composed of 5 developers and 2 testers. So that's basically your regime, right? We also have applied it for big enterprises. So that was just 5 agile teams where all those 11 testers were distributed across those 5 teams. We've also had projects out there where we have 15 or 20 agile teams. So, but what you need to change is your agile strategy itself from an organizational perspective. So it's not about Scrum on Scrum anymore, or just apply the Scrum rules over to all of those teams. Then it's about scaling agile, less framework, for example, or scaled agile, right? But from the testing perspective, that stays the same. So it's scalable.
Thank you.
Thank you. Any other questions? If not, then thanks again for your patience.